Hey everyone, and welcome to another lesson of Azure Functions University. This time I'm going to talk about durable functions, and not in .NET this time, but even in TypeScript. My name is Mark, and welcome Christian.
Hi Mark, happy to be here at the show.
Yeah. Thanks for your contributing this lesson. Yeah, I'm really looking forward to it. Before we dive into the lesson, let me share my screen and let's go through some of the lessons we've done so far. So we have lessons in GitHub, but also corresponding recordings on YouTube about HTTP trigger, about blob, about queue, about table, about deployments to Azure, and about Cosmos DB. And as you can see, most of the lessons has been written in .NET Core, but we're now also trying out some other languages. So today is actually the first time that we are introducing another language, durable functions in TypeScript. So I'm really excited by that. After the durable functions lesson, we'll do a lesson about configuration. That one will be .NET based again, but if you want to participate, you can file an issue on our repo, and our repo is here. This is the link, and you can actually translate one of our lessons. So feel free to translate it into JavaScript or Python, or if you have another idea about different content, then please go ahead and create a content issue. And it's up to you if you want to create it content then yourself, or we can collaborate on that, and you can even co-host the lesson like Christian is doing now. All right, let's start the durable functions lesson, Christian. Over to you.
Okay, then let's go. Let's get the party started with durable functions. So my name is Christian. I'm not originating from the Microsoft ecosystem like Mark is. So I'm from the SAP ecosystem that you will also see later. And that's also one reason why I dove into the topic of durable functions in TypeScript, because that's a language that's a bit more used in the SAP ecosystem. Okay, so let's start with the lesson itself. What will we do today? So first of all, if you have seen this format, we will go a bit about the prerequisites in order for you to follow along. Then, as this is a kind of a different topic than the functions that you've seen before, if you followed the Azure Functions University, we will do a little bit of, let's say, theoretical introduction to durable functions. And then we will dive into the code, starting with, let's say, hello world application, and then go a bit further in implementing a real world scenario and doing some things with the toolbox that durable functions comes along. So let's start with the prerequisites. Nothing really surprising there. So what we need is we need some kind of a folder where we put our code in, of course. Then we use Visual Studio Code with the Azure Functions extension that you probably know, that can be also used to create durable functions. Then there is one thing that is a bit special. When we want to do the development locally, we have to use the Microsoft Azure Storage Emulator. Now, this thing is kind of in maintenance mode, but that's the only way to get things running with durable functions locally. Usually, you would expect some cross-platform approach, and that's coming.
Yeah.
I think with Azure, there was some discussion around the topic that maybe the Cosmos emulator will do the job, or Azure. I think Azure is now the coming with support of durable functions.
Yes, that's true. Yeah.
So for those who are not working on a Windows machine, you have to connect to a storage within Azure. And last but not least, the Azure Storage Explorer. You do not really need that in order to develop durable functions, but we will use it in order to take a bit of a look behind the curtains how Azure durable functions work. Okay, then let me shortly introduce a bit of theory. I mean, it's university, so a bit of theory is fine, I guess.
It's good, definitely. It's and definitely needed for this topic, because this is definitely a bit of a more advanced topic than that we covered before. So it's good that we do this.
Yeah, absolutely. So let's take a step back and think about functions per se. So basically, functions are really a great way in order to make a serverless reality. Nevertheless, there are some, let's say, constraints, some guardrails that you need to respect in order to be successful with functions. Otherwise, you run into drawbacks, you run even into errors if you don't respect those things. And there are three main points that I like to highlight. First of all, functions must be stateless. So that's something that's just a matter of fact. That's how functions work. That's the nature of functions. Then there are 2 points that are more, let's say, guidelines that you should respect, but you don't need to do that. And that's functions should not call Azure functions. So you should keep them loosely coupled. And functions should do one thing, and they should do this one thing very well. If you respect those 3 points, you will really stick to the serverless paradigms, and you will be successful in designing and developing loosely coupled systems. And that's basically what we want to do. Now, when you think about what you do in your job, you will probably often have something like a business process. And you want to model that with functions. So you have a workflow and you want to model that with functions, and you want to respect those 3 guidelines. Now, how can you do that? One solution for that is depicted here. So let's say we have a workflow that consists of 3 steps. And in order to develop that, we will develop 3 functions, each representing 1 step. And we will kind of couple those functions via events or entries into something like a storage. So we have a function 1 that does the first step of the workflow. Then it takes the result, puts it into some storage functionality, or enqueues a message or something like that. And function 1 is done, and this message is then picked up via an event by the second function, which then does its thing, and the story continues until all steps are executed. Now, this is a great solution because this is really a loosely coupled system. It's an event-driven system, so that's great. But when you take a look at it from a, let's say, design time perspective, you will not really see how those things work together. You have 3 functions, and they are somehow coupled, but you do not, for example, see what's the sequence, which is not that great if you want to dive into the topic. Now, the second point is this storage functionality. You need it, and you really have to take care about that. And if you do serverless, I mean, you're basically such a lazy guy like me, you don't want to care about servers. And here you really have to care about that. So that's a drawback that's not that much fun. Now, if you also want to let's say, propagate some context over the different steps, you must store it, you must deal with errors in that case, if they occur, and so on and so forth. And last but not least, errors. Handling errors is one topic, but also finding errors in such a setup can be quite cumbersome. So it's really complicated. And now the question is, can we do better than that? And the answer is yes, and that's Azure Durable Functions. So what do durable functions bring to the table? So durable functions are really an extension to the Azure Functions framework. So it's not a second framework or something that's integrated afterwards. It's really an extension that seamlessly fits into the framework, and that allows you really to write such workflows code-based. Of course, there is no, let's say, magic fairy dust that gets you rid of queues and table storages and such stuff. So they are still there, but you do not have to care about them. It's all done by Azure Durable Functions behind the scenes, so they abstract them away. There is also something like a function state that is managed. and that's using event sourcing, the event sourcing pattern. I have referenced that down below and here. If you want to take a look at that, we will also see that when we look behind the curtains. Now, besides that, there is also, let's say, a toolbox that comes along with durable functions that helps you with some tasks that you want to accomplish. We will also make use of that when we take a look at retries and when we take a look at timers. Now, before we now start, let's take a look at the mechanics of durable functions, because durable functions are basically composed out of three moving parts. So first of all, we have the orchestrator function. That's really the central part of the durable function framework. And this is, as the name says, the orchestrator. So this is the thingy that dispatches the single activities in your workflow. The second type of function that's necessary to deal with is activity functions. That's really the basic work. That's where the work is done. That's where the single task that you want to do within your workflow gets executed. And these activity functions are triggered or scheduled by the orchestrator function. And the last part that we have is a client function. This client function is your gateway into the world of durable functions. So this is the function that you call in order to kick off an orchestration. So the client function triggers the orchestrator function, which then triggers the activity functions. And the client function also has a second job. It helps you with getting information about the status of the orchestration, because the orchestration is executed asynchronously. So you just get back some information, as we will see later. And then you have to interact with the client function in order to get the status of the processing, or to do some further things like terminating the processing. So let's do a little execution of durable functions on paper, so to say. Let's assume that we have two functions that we want to execute in sequence. So as depicted here within this pseudocode, we have a function that we want to call, and this function gives you back a result of the execution, and this result is then fed as an input to the second function that then does something and returns a second result. Now, how does this look like, or how does this behave now with durable functions? So first of all, we have here our three parts: the client, the orchestrator, and the activity. And we have two storage parts that will be used behind the scenes in order to schedule the activities and schedule the orchestrator. So first of all, we are first scaled down to 0, and you make the HTTP call to the client in order to trigger the orchestration. So the client wakes up. And what it does is it gets your request and then puts in a task into the control queue in order to make the orchestrator aware that there is something to do. Mm-hmm. After that, the client scales down to 0 and the orchestrator wakes up. This is now depicted here. So the orchestrator now picks up this task from the first queue, from the control queue. And well, the orchestrator knows what to do. So he will now schedule tasks into the task hub in order to trigger the activity functions. When he's done that, he's scaling down to 0 again, and the activity function is scheduled based on this entry in the work item queue, so in this queue. This activity function then wakes up, does its thing, and when it's finished, the orchestrator is, let's say, reinitiated it will resume its executions, replay the orchestration, and check if something more is to do. So in our case, activity function 1 is done. There is still activity function 2 to be executed. So he schedules a second task, and, well, history repeats itself. And when everything's done, all the single functions then scale down to 0 again. And the result is stored within the storage functionality and can be fetched afterwards by you via the client. So, yeah, that's it from the theoretical perspective.
Yeah, so to make a small summary, so this durable functions framework is especially useful when you're dealing with any business process that requires a certain number of steps with a certain specific sequence, or maybe things in parallel, which you want to capture in your code. So that's, I think, the real benefit of durable functions, that for developers, they understand code. So for them, it's quite convenient to describe the workflow in their code. So it's really visible what the workflow looks like, instead of just dealing with separate functions and separate queues, like the example you gave earlier, right?
Yeah, absolutely. So that's the code-based approach. I mean, there is a second approach, which is this logic apps thing, which you can also use within the Azure ecosystem in order to model workflows. But as a developer, I always struggle a bit with them. So I prefer...
it's meant for a different audience, right? Yeah, if you're more into visual workflows, then logic apps is needed perfect. Or Power Automate is also very visual. But if you're like code better, then you can use for durable functions. Yeah.
Then that's the way to go. Yeah. So it's a different persona.
Yeah. Cool. Yeah.
Cool. So yeah, that's enough for the theory. Let's do some things. Let's start with the code. So what I have is, I am now within a directory that's called Durable Function App, and within this directory, I now want to create my first durable function project. And what we will do is we will make a little hello world scenario where we have a orchestrator that executes an activity function in a sequence 3 times. And with each execution of an activity, we will have an input parameter, which is a city name, and the activity will return hello city name as an output. And after all activities have been executed, we will have 3 answers or 3 replies that we can fetch from the durable function. So let's start first with the client function, so our entry into the durable function world. So we already have the directory, we already have code up and running, and as I said before, we will now use the Azure Functions extension in order to create a new functions project. We will put it into this directory, and this time, kind of a premiere, we use TypeScript. Because there is quite some things that are really made great by the people who did these templates that really help you when you do something with TypeScript. So what we need first is the HTTP starter, and we call it durable function starter. So you will not see me type, because you don't want to see me make typos. Yeah. So here we go. We have our durable function project setup, and there is quite some things that happened here. So what you will see if you are used to work in the world of JavaScript or TypeScript is that's a typical project setup. So what we have here is we have our package.json file, which comprises some meta information about the project. We have all the dependencies down here for our Azure Functions, for our TypeScript version. And we also have here some convenience functionality that support us with building the project, with starting the Azure Function runtime, with a pre-start step. So that's already quite convenient. We also get the configuration for free for the building of the TypeScript sources to JavaScript. So that's all there in place. Now let's move on and check the function that we just created. That's in the folder called Durable Function Starter. That's how we wanted to name it. And we have two files here. One is the function.json file, which contains the configuration of the function. And one is the index.ts file, which contains the code of your function. So you have a very clear separation between configuration and code, which is nice. Within the function.json, you have basically the information about the binding. So if you listened or watched the first episode, we have an HTTP triggered function. So there is nothing surprising here. So we have here this HTTP trigger with the methods that we can use, HTTP verbs that we can address it. We have the output binding. And we have one thing that's now special for the durable function world. And that's here another binding that defines the type of the function. So we created the client function. So the type is orchestration client. And this definition makes the function runtime aware of that this is a client, and this client is allowed to call an orchestrator. We also have here the script file, which defines where the transpiled sources will be stored. And we have one additional thing, and that's here. So we have the route. Now, if you call the client function, the client function has to know which orchestrator to invoke. And this is done here via this route. So we have orchestrators, and then we have to hand over the function name of the orchestrator in order to dispatch the work to that orchestrator.
And so this is more like a convenience method right now, because you could also hard code the orchestrator name in your client function. That would also be possible. But this is now a very flexible way to start any orchestration from just one client.
Yeah. So you can replace that one and put in that hard coded. Then you don't have to think about the name. But this way, and this is something that we will use. It's more flexible.
Yeah, I like it.
So that's all about the configuration. Now let's take a look at the code. Now there is already some stuff here. So what we have here is two imports of functionalities. One, of course, the Azure Functions functionality, and then the import of the Durable Functions extension. Now, as you can see, we have here this red line underneath. That's because we have not yet installed the Durable Function npm package, and this is something that we will do now. So we do an npm install of the package. So this will quickly download the package and put it into the package.json file. And there is one thing that you also should do. Because we are using Node, we have to make the system aware of the types that are used in Node. This is something that we will install as a dev dependency. So this is necessary for building the project. So now usually the red lines should go away, but since I don't know some updates, the refresh does not really work. I don't know with which version this came in. But a restart usually does the trick. Ta-da! No more red lines underneath, and you now also get this nice functionality that you see what is happening here. So we have this HTTP starter Azure function, which is a classical asynchronous JavaScript function or TypeScript function that gets in the context and the HTTP request and returns a promise to the caller. So representing the the asynchronous nature of the function. Now, the things that happen within the client function is not very much. So basically, what the client function does, it gets a client, an orchestration client instance based on the context, and then it starts up a new durable orchestration client, making use of this function name that's handed in via this HTTP request parameters. And it also hands over the body of the request that can then be used within the orchestrator. Then it does some logging and tells you which instance ID was created. And then what we will see later is it will return some default status page that tells you the instance, the ID of the instance, and tells you the URIs that you can use in order to interact with the durable function. But we will see that later.
Okay. Good. So here we're using the client binding of durable functions to create a new instance of an orchestrator function. So that is what's happening on client.startNew. So the start new means, okay, you start me a new instance of this orchestrator function, and the name I'm getting from the request parameters. Exactly.
So that's already it for the starter. So there is no real magic in there, and it's really quite lean. Now, in the next step, what we want to do is we want to call or to create the durable function orchestrator. So what we want to do is we want to create a durable function orchestrator. We call it very creatively durable functions orchestrator. And yeah, then again, some things are created. So it's a little bit chatty, so there is quite some explanation in here. I don't know, I don't like the semicolons, so I'll put them away. So let's get things cleaned up. Okay. So again, we have these two parts that are playing together. We have the configuration. Now here again, we have the specification. What type of function do we have? And we have an orchestration trigger. So this is the type of the orchestrator. And that's basically all when it comes to the configuration. We also, of course, have the code, which, just shows you that we are dealing with an orchestrator. And this orchestrator is using a functionality from JavaScript in order to make this behavior that we described before in the theoretical part reality, and that's a generator function. A generator function can be seen by this little asterisk here. And a generator function is a special function within JavaScript. When you call a generator function, you will not directly execute the code body of that function, but you will get back an iterator that will then be executed. And you will then iterate over the body of the function. And the iteration will always stop when this yield keyword is hit. And that's exactly the behavior that we want for our sequence or sequential execution of our steps. So what do? We define an array that we then afterwards return to the caller. And we now call 3 activity functions. And we yield them. So we call the function, and then the processing stops until the function is done. And then the orchestrator is resumed, and the next activity is called. Now, this call activity has 2 parameters. First one is the name of the activity to be called, and the second one is any type of input parameter that you want to put into the activity. Now, I guess there is one thing that you will see immediately this is a string. So the activity function is defined by a string, and if you only do half of the errors that I do when I do coding,
it can be a bit tricky.
You might sometimes mess that up. So and I know that in .NET there is, I think, a very clever way to deal with that.
Yeah, there's an analyzer which then checks the names between the activities and the orchestrator. Yeah.
It's not there for JavaScript and TypeScript. Let's put it that way.
Okay. Yeah, that's it.
So you have to deal with that.
Yeah.
I mean, you can do put in enumerations or something like that, but anyway, you have to deal with that stuff. That's kind of a downside. Okay, then let's move on. Let's move to the
maybe one question still about the calling the activity, because there's an input argument, but can you have more input arguments?
You can have, for example, you can hand over the complete context. So usually you would then hand over an object, a JSON object.
Exactly. Yeah. So you just limit it to one. To one type indeed. So if you want to hand over more stuff, then you have to make some kind of complex type and then hand over that type.
Yeah, cool. Exactly. So that's in the TypeScript world, it's usually a JSON serial input. I don't know if it's the same in .NET.
Yeah, exactly. Yeah.
Okay. So then let's move on to the activity function. So we will now create a durable functions activity. We will call that hello city, because we call cities. And again, we get our things set up. So we have here the configuration of our activity, and we have here the binding, which is of type activity trigger. So this thing can be called by an orchestrator. And again, we have the script file. Now, for those of you who start with JavaScript and move over to TypeScript and change something within the orchestrator by at the name of the called functions, usually within JavaScript, it's sufficient to rename the directory, because then the function runtime will pick up the right function. With TypeScript, you also have to correct or to adopt the target directory for the transpilation. Something that usually happens, and then you're really looking for the error. Let's shortly check the code. So no surprises in here. So what we have is now really an asynchronous function that gets handed in context and returns a promise of type string. That's the default. And then it returns here via a string template hello and the context bindings dot name. So that's what we hand over from the orchestrator. Now, as you have seen, I have now intentionally renamed the activity, so it's Hello City. So we here have to make sure that we really call Hello City. Otherwise, and to save the change, that's also important. Okay, so now we have all the moving parts in place. I hope I did not forget anything. I don't think so. Oh, no, of course, I forgot one thing that I usually forget. Exactly. We want to execute the stuff locally. And for that, we have to make the corresponding setting in the local settings.json file. And it's this magical string called use development storage equals true, which will guide you to this error. If you do not put that in, you will get an error when starting up, and it will take quite some time to start up. So that's also an indicator where I usually know I forgot something. So here we go. Now we can call, based on the package.json, on the script files that are in there, npm run, and it will start. So this will now trigger the build, and this will now trigger the starting up. While this is happening, I have already started my storage emulator. As you can see here, that's the simple executable. It has 3 different endpoints. We're using the table endpoint, and you can check if it's running here. And now the function is up and running. So what we see here is we have the durable function starter type, which has this endpoint. We have the orchestrator, which is the orchestration trigger, and we have the activity trigger.
Cool.
Now, yeah. So within the script of the lesson, I used the REST extension, REST client extension of VS Code. I will now here, for the sake of readability, I will use Postman. And I have prepared the REST calls. So what we have here now is the HTTP endpoint, and we have here the name of the orchestrator. So let's execute that one. And yeah, we get this status, this default status. With the ID, with the status query, we have several other URIs like purge history or terminate the execution. We are interested in the status query. So we will now go to that one, call it. And what we will see is that the runtime status is completed. That's good. And we get an output, which we expected because that were the 3 activities that we called when we did the code. So we have the Tokyo, the Seattle, and the London. So that's, whoopsie. So here we go. That's what we have. Now let's take a look what happened behind the scenes. So we go for that to the Storage Explorer. No, this is not what we want to see. I have already connected my local development storage here. You can do that by the connection button, attach a local emulator. If you did not change something from the setup, just go with the default, then everything should work fine. And here we have now 2 tables. We have the durable functions hub history and the instances. Let's take a look at the instances. So it's really a bit big here. This is kind of, I see it as a summary of the execution. I don't know if that's really the exact statement to summarize that table, but this is really where you see, based on the partition key, which is the ID of the instance, what happened, what's the runtime status, what's the output, which name of the orchestrator was used. So you have all the basic information here. So that's good to have a first impression what happened during the execution. Now, what's, from my perspective, more interesting when you want to take a look at the mechanics is the second table. Because here we have this event sourcing representation of the execution of our function. So we have again the partition key, which is the instance ID, and now we exactly see what happened in sequence. So we have the orchestrator that started, we have the task that got scheduled, we have the orchestrator that completed, so it scaled down, then the task was executed, the orchestrator restarted, did the replay, and so on and so forth. And what's also cool from my perspective is you also see the intermediate, you see the activities that were called, and you see the intermediate results, if you want to call it like that. So the result of each activity and the final result. So and the orchestration status, of course. So that's already, from my perspective, quite helpful if you want to see what went wrong and where something went wrong. But it's also super usable from my perspective if you want to wrap your head around how durable functions work.
Yes, yeah, especially because the orchestration starts and then it stops and then it restarts and then it stops again. So yeah, you can see it quite clearly now in this table. Also, if you put a breakpoint, for instance, in your orchestrator, you would see that it would continuously run into this breakpoint. So that's a good moment of realization that your code will be executed a couple of times, depending on how many activities are in there, and not simply just once. You probably used it. Okay, I have one piece of code, so my code will just go once right through it. But no, your orchestrator will replay over and over until all activities are done. So this is a good way to realize that.
Yeah, definitely. And what you also see is really, it's event sourcing by somebody who understood event sourcing, because the names of the events are really events.
Yeah, the past tense. Yeah, exactly. Yeah.
So past tense are not created, updated, deleted, but really it makes sense from a business perspective, so to say.
And as a developer, you don't need to know really about the details of this table, and it's also not really advised to really use this table and query it yourself, for instance, because Azure Functions has its own API to actually manage everything around it. We'll come back to it a bit later, but it's nice for you to know that at least this is there.
Yeah. So yeah, exactly. So as a developer, you always, if you see something like that, you want to interact with that. Don't do that directly.
Yeah.
Okay, so that was already our very first durable functions. So what you see also from the console output, you have some basic logging here. So we are now here in the standard run mode. So it's not the verbose mode. So we get some basic information there. So everything's there. Okay. I will now shortly clean up the emulator so that we do not have to select the instance ID again and again. So just for the sake of the demo. Now, what do we want to do next? Next, we want to dive a bit more in a real world scenario. So go one step beyond Hello World. And what we want to do is we want to interact with GitHub. We want to take the name of a GitHub repo, and based on the name, we want to fetch the login name of the user that owns the GitHub repository. And then we will want to know a bit more about the user in a second step by fetching additional information. So a classical two-step process. You first need to know who owns the repository. And then in the second step, you get the additional information about that.
Sounds good.
Okay, so then let's dive into that one. As we are lazy and we want to make use of the flexible starter, we will simply reuse the client function and start with the orchestrator. So we will just create a new orchestrator that we call GitHub Info Orchestrator. Okay, so we will get rid of these things. We will get rid of those things. Semicolons. Nobody likes them.
Yeah, you shouldn't go venturing into .NET then if you don't like semicolons.
Now that's really something specific about JavaScript that they introduced, I think, a few releases ago.
Yeah.
So I started with .NET, but somehow my time wasn't allowing to dive deeper. I think it's cool, but I would not be able to give a lesson in that one.
No, but I'm very happy you're doing the TypeScript one. So this is cool. I really like it so far. I learned a lot from this. So please continue.
So okay, let's go on. We need two activities, as we said before. So one for the information of the repository and one for the user information. So we call that one get repository details by name. Those things. Okay, and we need a second activity, which perhaps we should first define that it's an activity, and then we should put in the name. Okay. So Here we go. So with respect to TypeScript, I will this let's say code that I will put in will not be, let's say, completely production ready. I made it a bit more chatty to make clear what happens and how things work together. So it's not perfect from a TypeScript perspective, but I think it does the job. At least it works.
Okay.
Then we need one more thing from GitHub, and that's an npm module. It's a library, SDK, however you want to call it, that makes your interaction with the GitHub REST API a bit more fluid. And that's called OctoKit Core. So what we will do is we will npm install it. And here we go.
Yeah, I've used it in the .NET world as well, OctoKit, and it's really very nice. It's really a great job to make it sit with that library. Yeah,
it's really useful. Yeah, definitely. Yeah. Okay, so now let's start with the orchestrator. So let's save it. Save it. And here we are within the orchestrator. Now I will just copy in the code and then walk you through it. Because that's a bit easier to explain. Okay, so what are we doing? So again, we have this calling of the activity. We call first the activity get repository details by name, and this time we hand over the input data that we get in from the client function. So this is here within the context binding data input, where we will pass over the repository name when we do the HTTP call. And what we then get back from that activity is a user ID. And here we say, okay, we want a string. That's also then the thing that we have specified within the activity in the promise. Then we have to transfer this user ID to the next activity, and we do that by attaching it to this input. We could also hand it over separately, not making use of the context binding data. I just wanted to show you that if you want to reuse the context binding data input, you can just attach it and hand it over to the next activity.
Cool.
So that's kind of the coin has two sides. I mean, you do not have to specify anything because you can attach anything to a JSON object, which also means there can be anything in the JSON object. Well, and then you call the second activity, which will hand over the user infos, absolutely the same code as we did before, basically, yielding the second activity. Now, jumping into the get repository details by name activity. Here, we first of all have to import the dependency to OctoKit. And I will simply copy the whole code. And then let's take a look at it. The first two lines, or the first 3 lines, are basically interacting with OctoKit. So I create a new instance of the OctoKit core SDK. I define a query that I want to hand over to OctoKit, which consists of the repository name. And I specify I want that in the name of the repository. So that's my query. And then I want to get the search result. And to do that, there is a request method at the OctoKit SDK, which then gets provided the endpoint where I want to make the call and the query. Now, as we have not an exact query, but we say, hey, the name should be somewhere in the name of the repository, we have to filter out the exact match from the search result. So we get here this search result, which is a JSON object that has quite some stuff in it, especially this data array with the items. And within the array of the items, we can use the find method. And with the find method, we just hand over an in-place function. where we say for each item, execute this function. And if it's true, then give us back the result and finish the processing.
Right. Yeah.
So just a little bit of JavaScript magic here. And then we hand back just the login, because that's all we are interested in. That's the first activity. And the second activity, I have to find it. It's the get user details by ID. So we have to do the same thing. First, we have to import OctoKit. And then we have to put in code. And this is a bit different than the first call. So here we, again, instantiate OctoKit. We just define an API path, because the user info is really located at one API path, at one API endpoint. And then we just shoot the request to OctoKit and get the research result. And then the data, what we have to do here is we have to return JSON.
JSON, right? Yeah. Okay.
Yep. Now this is a super dirty trick. So this is nothing that you would do in production. It's a widening cast and a narrowing cast, and
right. Yeah.
It's an example that everything is possible within JavaScript. Usually, you would probably implement an interface here for that.
Right, a specific type that you expect back. Yeah, exactly. Yeah. All right.
Yeah.
Cool.
So just as a warning. Good. Now we will start things again. So we will just do an npm run start. Now the project gets rebuilt. While it's rebuilding, I will show you one thing that's also quite handy for the TypeScript users. You have here this dist folder where all the sources go to.
Mm-hmm.
And what's really useful is you also get out of the box the .map file, which is the file that makes debugging possible.
Ah, right. Yeah.
So because from you put your breakpoint into TypeScript, and due to the mapping file, it knows where to stop. And that's all out of the box. So you don't have to do anything or to think about anything. Put your breakpoint here, press F5, and you're good to go.
Nice. Cool.
Absolutely. Yeah, so here we go. We have our go away there. Our real world endpoint. So again, we have this generic endpoint. We have the GitHub info orchestrator, which is the orchestration trigger.
Yeah.
I have put that here, and I have here as a body the repository name. I put Azure Functions University. I don't know why, but I think that's a good repository. And I'm sending things out. So again, as before, the response as expected. And now let's see if things worked as we expected it. Ta-da!
Completed. Yeah.
Live coding, always putting your heart rate up.
Yeah.
So it's
and
complete.
there's my information. Yeah, indeed. Yeah.
Here we have the repository name, and now we have all the information that we need to know with the respect of GitHub about Mark.
Cool.
So it's all here.
Nice. So it's a good real life example.
Yeah, it's. I think this is what you will do mostly of the time. So you will have some SDK that you interact with, and you will have some sequence of steps.
Exactly. Yeah, indeed. Yeah. And right now you're returning something from an orchestrator, so you can use the API to get the result back. But quite often, maybe your orchestrator ends with sending some data to some storage somewhere, or maybe your final step is pushing some data to someone else, their API. So it's not necessary that you have to return data from an orchestrator. That's optional. You're in control of your own flow and what your end state is and stuff like that.
Exactly. So you can also use bindings there as before. So it's not forbidden to use other bindings now as an output binding, for example, in order to store your data. That's all fine.
Yeah, you can mix and match indeed. Again, tables or Cosmos DB as an output binding in your final activity, for instance. So you save it something very easily. In Cosmos DB, for instance. Yeah.
Exactly. Cool. Okay. So time is running. I'm talking too much, I think.
No, it's going quite well. I like it.
So now let's, as we are in the real world, there are errors. So we're calling some downstream API. And what definitely happens are errors. So maybe there are, let's say, temporal errors. So the API may not be reachable, but that's just a temporal event. So if you try it a few seconds later, you will get the result. Now, what we want to use now is something out of the toolbox of durable functions, which is a retry functionality. So we can use automatic retries within durable functions in order to deal with these kinds of errors. And this is what we will do now. First of all, I will kill the execution. I will shortly commit that stuff. That's also something that you, by the way, get out of the box by the durable functions templates. So you get your .git ignore, you get your git initialized. So that's just cool. So now we will create a branch that we call retry, and we will check out that branch. So what will we do now in order to make those retries? So first of all, when we want to do retries, we want to specify some attributes of the retries. So, for example, how many attempts do I want to make? When will I do? When should the function runtime do its first retry if we run into an error? And some other stuff. So I will shortly. Well, not shortly. I will copy that bit by bit. So I will first define the configuration. So first of all, we define the retry interval in the first retry interval in milliseconds. So when will we do the first retry? And then we will define the max number of attempts. So let's say we try it 3 times. Then we want to specify oops, that's the same as before, right? No, it's the max retry interval in milliseconds. Sorry, my fault. So that defines the maximum interval between retries in milliseconds. And then we have the timeout. So when do we really want to abort everything? Those things come into play. So there are two more options that you can put in, because we are now dealing with a linear retry. So wait 1 second, retry, fail, then retry again. You can also do some more sophisticated stuff where you have some let's say curve on how you want to retry, because perhaps after the first retry you want to wait a bit longer, or you want to wait a bit shorter, something like that.
Yeah, exactly. Yeah.
So what we do then is we have to create an object for the retry options, and that's available via the durable functions import, and that's the retry options object. That has a constructor that takes 2 parameters, which is the first retry and the max number of attempts. That's kind of the minimum attributes that you need. And then in order to put in more configuration information, you can use the attributes on the class level or on the instance level in order to make these parameters available. Now, if you want to use this functionality, we have a second method available at our durable functions context, which is called activity function with retry. And this method then has a second option that's called retry options. So that's what we put in here. So we have our retry config. Put that before the input parameter. don't like that. Why don't you don't like that?
It needs the with retry. It's now called activity.
Right.
Yeah. Yes, perfect.
Too fast. Exactly. Yeah. So and that's all the magic that you have to do.
Cool. So if GitHub is now a bit, let's say, unresponsive or is super busy and we won't get a result the first attempt, then durable functions will make sure that we wait for a second, but then we will then it will try another call at the API.
Exactly.
Right.
Exactly. Cool. Now, as the GitHub API will not be busy now, or at least I don't think it will be, we have to make a little bit of a trick. We have to cheat a bit. So what we will do is, wrong folder. We want to do some trick, some cheating. What we will do is we will add a second parameter to the JSON body, which is called raise exception. And when we hand over this raise exception parameter and set that to true, we will just throw an error. So we will make sure that this function fails, no matter what. And that's it. So we have our activity with retry in place. We have our enforced error in place. Let's give it a try. I will just shortly clean up my storage emulator. Start.
Yeah. This cleaning up your storage emulator is actually good advice while you're still developing and then adding function, removing functions, and changing your arguments. Because since the state of your orchestrator instance is kept in storage, and if you're changing a lot of things in your orchestrator, then your definition of your orchestrator might not match anymore with the state that is captured in table storage. So while you're developing, it's a good practice. You need to clean this storage emulator stuff regularly.
And it also gets us cluttered by a lot of tries because you always have to check then which instance was I on. Now it's easy because it's one instance.
Yeah, indeed. Yeah.
So let's first check that we did not mess anything up. So let's just call it like we did it before. We go to the endpoint. We call it. It's completed. We again get the information. Okay, cool. Good. So we did not mess things up. Now let's do this little trick. We say within the body of our request, hey, raise an exception. Set that to true. So we send that out. Again, it's an asynchronous processing, so we get the status query URL. We do not see if something goes wrong. Now we wait a bit because 1, 2, 3 seconds until things are through, and now we check what happened. And what happened is
it failed.
It failed. No surprise because we enforced it. Now let's check what happened here. So now we have two things here because we first made the real call and then we made the second call. So what we need is the instance ID. And we need to do a little query here. We sort it. And now let's check what happened.
Okay.
We have the orchestrator, the task scheduled. Okay, fine. The task failed.
Right.
Not fine. Now, what does the orchestrator do? The orchestrator created a timer. So there is some functionality called timer that's created, and the orchestrator kicks that one off. The timer fires after the time that we have specified within our configuration.
Yeah.
And after that, the orchestrator tries again to schedule the task. Of course, the task fails again. And the story continues until the timer fires its third time. Until the timer fires the third time, the task fails its third time. And the orchestration finishes with a failure.
Yeah.
That's it. Now, what we can do now is we can make a little. Of course, we see that also in the log.
Yeah, we see errors here as well. Yeah, that's intentional. Yeah,
that's with the nice red color. That makes you a bit nervous if you see that. what we can do now, when we think about the theory part, and as we discussed with the Hello World function, we have some replay logic in here. So this function gets executed again and again because it's the orchestrator.
Yeah.
So now we can cheat a bit. That's something that we cheat now for the demo, but this is also something that you can use if you want to execute some code only in the first run. In the very first execution of the orchestrator, you have an attribute at the durable function context that is called isReplaying. And when the orchestrator is executed the first time, it's false and then it's true.
Yeah.
And what we do now is we just change this parameter that we get in as an input.
Right. Yeah. Because initially we set it to true. So initially it will fail, but then as we replay, you set it to false. So then we expect it to succeed, right?
Exactly. So let's see if
Nice.
this little trick works out.
Yeah. So normally you wouldn't do stuff with, of course, well, maybe if you like a bit of chaos engineering, and maybe you indeed intentionally are doing this stuff to see how the rest of the system works. I can imagine you do that as well. But indeed, you can use the isReplaying for other purposes, like you mentioned. So that's nice. Yeah.
I don't think it's intended for that. It is really about that.
No, but it's a nice, also again, a nice insight in how you can use the durable functions API.
Yeah.
There's a lot in there.
Yeah, absolutely. There's a lot more than we can tackle today. So let's do the retry again, and let's say we raised the exception, right? So we enforce the exception. So we have it here. We go over here. Let's see. We have it completed.
Completed, yeah.
So our little dirty trick did its way. And we can also, I don't think that we need the query. We can refresh it. So as we see here, the task failed.
Yeah.
Good. The timer was created. The timer fired. And I'm running in the replay.
Yeah.
The input parameter is overwritten. And the task completed.
Yeah, and there it completes. Yeah, nice.
So that's the trick.
Very cool.
Okay, so nearly there. I hope you still like it. So let's clean up and go to the last part of today's session. As we have seen now, we have a timer within the durable function toolbox. It's kind of working behind the scenes. The question is now, can we also get that working for us? And the topic would be circuit breaking. So let's say the API does not raise an error, or you get an error in the processing, and an exception is coming in and you want to retry, but you call the API and you do not get anything back.
Right.
And you're waiting and waiting, and you want to break that. And this is something where this toolbox again comes into play, and where you can use this timer things. So what I will do now is I will implement such a simple circuit breaker. So retry. So we just get those things away. We go back to main branch of our to our repository, and we will create a branch that's called timeout. Check out. Okay, so let's start again. Let's see. Let's start the orchestrator and something. What did I do? Oh, it seems that I wrote to the main branch. Oh, that's cool. So no problem.
Oh, the previous one, yeah, okay. Yeah.
Previous one, yeah. So let's just put that stuff away. No problem. just call activity as usual. So get rid of the configuration.
Get rid of all the retry stuff. Yeah.
And that should do it. We anyway have to revisit the activity. We will do that in a second.
Okay, cool.
Now, what we have to do is we have to install a package that's called Moment, which helps us with handling dates and times.
Yeah.
Now, this is the package that's referenced in the official documentation of Azure Functions. This package is in deep maintenance mode. So it's not really supported anymore, and it has one drawback that it's not documented, because the documentation. So let's be fair, the documentation only deals with JavaScript, and due to the point that this is a bit older module, and it's not using the ECMAScript 6 way how to deal with module imports, we have to say, hey, also accept the old stuff, the common JS stuff, how to deal with modules. So we have to adopt the tsconfig.json. That's something that you will immediately see when you build the project, and that you will then probably Google. So I did it that way.
Cool.
Okay, now let's go for the timeout within the orchestrator function. So we'll just put the code in place.
Yeah.
So what do? We say we want a timeout after 3 seconds, because then if the API is not answering after that point in time, there will be no answer. Yeah. Then we defined a deadline, which is where we make use of this moment function to convert the UTC time to a real UTC time, add something, and give back an UTC time. And we take the current execution time, which is available via the context, as you said, via this API. Yeah. And then we add this timeout. Now, next. Yeah.
Yeah, well, one thing to notice here, because we are accessing the current UTC date time here from the context, and why is it in there, and why can't you use, let's say, another way to get the current date timestamp right now, and that's because of the replay nature of the orchestrator, right? So by using this exact attribute, current UTC date time, we have a safe way to get the current date time, because otherwise, when it will be replaying, you will get a new changed instance of that UTC date.
Exactly. Yeah, perfect point. I forgot that one. Yeah. Because of the replay nature, you will run into real problems there.
Yeah.
Now, what we do is, or what we want to do is, we want to start a little race between the timeout task and our activity task. And what we do is, we do now not yield the activity, and we do not yield the creation of a timer, but we just create the task itself. For the timer, we have a method here on the durable function context, and we hand over this deadline. Now, for the activity, we do the same. So just not to make any errors. So now we have 2 tasks in place. And now we want to start. So kick off a race. And that's again done via the keyword yield. And then we say durable function context, if any of these tasks return, give me the winner. And then I do something. So this any just gets an array of tasks. It can be 1, 2, 3, 4, 5, whatsoever. When the first one returns, this will be handed back to the caller.
Right.
Nevertheless, the other tasks are still running. So they do not get interrupted just because the first one is finished.
Okay. Yeah. Good point. Yeah.
And then we have a little logic that we need here. So what we do is we determine the winner. If the winner is the repository details task, we do basically the same stuff that we did before. So we extract from the result the user ID, hand it over, and call the next activity.
Right. Yeah.
If the winner is the timer tasks, we throw an error because we say, hey, something went completely wrong.
Right. Yeah.
Now there is one thing, and I mentioned that in this tip here, which is kind of a trap. So what you have to make sure is you have to cancel the timeout task, and there is a method for that, and it's called cancel, which kills the timeout task. Now you do not have something like that for the activity. So the activity will be running, and if you have now a configuration within your function app that allows a function to run for 10 minutes, it will run for 10 minutes, and you will get charged for 10 minutes. So that's that's it for the orchestrator. Now what we want to do is we want to do a little trick again. Because again, we will not get a timeout. So we will do a little thing that when you are in the JavaScript world, you probably know. We will create a little function that will send the processing to sleep. It's an asynchronous function, so it returns a promise. And the promise can be resolved. And for the solution of the promise, we set a timeout, which we define here. So we say, please wait. I add to 10 seconds. It's okay. So this function will just sleep for 7 seconds, and then we'll execute. And here we say we wait for 3 seconds, so the timer will wait. So now let's see if I made any errors. So full risk now, because we cannot check. We already have the sleep in there, so we cannot check if we just broke the orchestrator. This is now really on the edge. We have the instance ID. Everything is there. We can now do the standard call. We just need the repository name.
Yeah, right.
We send that one out. And then we wait a bit. Because it will wait now for 3 seconds. Can already open up. And here we go. It's probably one of the rare times that you like to fail a function, but I like to see it failed here. The repository information called timed out, that's what we wrote to the console.
Exactly.
You also see that somewhere in here. Reason, no. I thought I wrote it somewhere in the,
information called time. So it comes back.
So now if you take a look at the at this little history, we see that the timer got created, task got scheduled. So this was kind of the task any method that we called. So both started to run, and the timer fired first. And this caused the orchestrator to fail. Now, what you see here is the first task completed. And
because it still came back.
Transferred.
Exactly. After the 7 seconds, right?
Exactly. After the 7 seconds, it was executed because GitHub API is stable. So it's available, and that's something that you have to keep in mind when you deploy it really to production, because things like that might happen.
Indeed. No, this is good to know. But your orchestrator is in charge, and you're explicitly saying, okay, I don't care in this case if it completes, because in my orchestrator I've made a decision to not care for it, and I'm doing something else.
Exactly. Due to the fact that the orchestrator knows what to do, you do not run into unwanted side effects or errors.
Exactly.
Except for the functions running.
Exactly. Fair enough.
Okay. Oh, that was quite some stuff, I would say. And we're through.
Yeah. You also prepared some homework, right?
Exactly. I even prepared 2 homeworks.
Yeah. Exactly. Yeah. Yeah.
We have here one homework that we would hand over to you, which is kind of a variation of the stuff that we just did, making use of the Bing Maps API. Now, this API is, in that sense, a bit more tricky, that you need an API key that you need to get via this page that we referenced here. So it's for free. You get the API key. You have to hand it over when you make the call to the API, but there is no complicated OAuth 2.0 flow or something like that. You just need to hand over the API key.
Right.
And there is also one drawback. There is no, like the OctoKit API, the OctoKit SDK. You should use Axios as an HTTP client. That's kind of a de facto standard when you work within the JavaScript and TypeScript area.
Okay.
So, and what's the point? So we use Bing Maps API in order to hand over our address. We get back the geo-encoded data. And based on the geo-encoded data, we can make a local search on the type of business entity. So let's say I want to know which coffee shops are around my place, or which restaurants are around there.
Right.
Yeah. And that's something that you can do. We have, of course, the resources available for you, but give it a try first. It's really fun from my perspective to work with that, and usually you really succeed quite fast. There is one thing that I would recommend: if you commit your stuff to GitHub repo, put the API key into your local settings.json.
Yeah.
That's also something that I forgot to mention. We now quite put all the configuration in the code, put that into your local settings.json.
Yeah, I fully agree.
And reference it via process.env, so via environment variable.
Exactly.
So that configuration code should not be in the same place.
Yeah, which also ties into our next lesson, which will be all about configuration.
Exactly. Yeah, looking forward to that one. And if you do that, we're happy to hear from you. Here's the hashtag. Tweet about it. Tweet about the progress.
Yeah,
we really like that. Now, as I said before, did I mention it? I'm from the SAP area, and SAP now don't stop the YouTube stream. SAP evolved over the recent years. There is some cool stuff around SAP now in the meantime, and there is one thing that you can use and make all your colleagues jealous because you're working with SAP, and that's calling an SAP APIs in sequence. There is something that's called SAP Cloud SDK that allows you, or gives you a Fluent API to interact with an SAP S/4HANA system. And you don't need an SAP S/4HANA system to do that, because there is a sandbox available at the API Business Hub. So all you have to do is to sign up, get a free API key. You will not get any calls by SAP because you signed up, so don't be afraid of that. You have your API key. You can then interact with an S4 system, making use of the SAP Cloud SDK. And that's kind of a second homework. I described it in more depth because it's not completely self-explaining. I mean, okay, it's
a bit more, right? But a very good use case also for Drupal functions, right? With the multi-step and stuff like that. So if you want to dive deeper, I think this is a nice one to.
So it's also might spark the ideas about how you can interact with SAP, mix up both worlds, Azure and SAP. So that's all possible now.
Exactly. Yeah. No, that's a very nice touch. Cool.
Okay, so now we are a bit behind time, but just a bit.
Perfect. No, sometimes you have to take your time, right, to explain all these things. So thanks very much. Yeah.
Yeah, and we have all the references here, all around the generator functions, if you wanted to take a look at that, how that works, and of course about all the stuff that has to do with the Azure Durable functions and the functionalities that we showed today.
Yeah, because it's even Durable functions is a much bigger topic, as we're just scratching the surface now. Maybe you can come back for another Durable function related topic somewhat later.
I definitely would like to. Yeah, definitely.
Okay. Yeah, cool. Thanks a lot, Christian. That was a really useful and insightful lesson with lots of examples. So it was good also for me to follow in a different language than .NET. Thanks a lot. Let's
Welcome.
switch back to our main lessons and what we have till now. So this was the first TypeScript lesson that we did. Hopefully the other lessons will catch up in languages as well, so we can offer more languages. So if you want to participate in adding language translations, please drop me a note. And we will back next time in 2 weeks, and we're talking about how to deal with configuration and application settings in your Azure Functions. So until then, everyone, bye-bye.
Bye.